for the first lesson out of chapter 1, looking at relations and functions. So some vocabulary, some examples to get things started. When looking at functions, 3 vocabulary words: domain, range, and then the function itself. Domain is your list of inputs, all inputs. And that would be your x values. So range then would be your outputs or your y values. Sometimes this will be a list of values. Sometimes it will be written as an inequality. X is greater than 2. So any number greater than 2 would be your domain. And then range, same thing. It can either be a list of values or it may be a inequality. Y is between 0 and 10. So 0 is less than or equal to y, which is less than or equal to 10. So we'll look at some examples of that in a moment. And then a function. For a relationship or a relation to be a function, each x must produce or have only one y value. Okay, so a lot of times functions are thought of as like a mathematical machine, right? So I have the function machine here. We have our in, and then we have the out. Okay, so this would be your domain, what goes into the function. And then these are your range that comes out. Right? X goes in, Y comes out. Right? So if I drop a 1 into the machine and a 4 comes out, right, I can start thinking about what this function machine is doing. So then if I put a 4 in and a 7 comes out, I can see that my rule for my function machine is to add 3. Right? And so no matter what I do, it has to add 3. Okay? So that would make a function. However, if I put 4 in again, and something different comes out, right? Now I no longer have a function, right? My machine is broken because it's not doing what it needs to do every time, right? So if you get 2 different outputs for an input, then it is no longer a function. And we're going to look at some more examples of that as well. So here, looking at example 1, we are asked to list the domain. So our domain here would be 2 and 8, right? Because we have 2, they're listed for us right here, right? 2 and 8. Okay, my range then is 21, 25, and 30. And then we are asked the question, is it a function? So to check for functionality, if you are given a table, right, we need to look. 2, it goes into the function machine, 21 comes out. 2 goes in again, and 25 comes out. So this is not a function because the one input does not give a designated output, right? 21 went into the machine, or 2 went into the machine. 21 and 25 were produced from that. Okay, so that makes it not a function. Looking at example 2, my domain, my x values are going to be 5, 10, and 15. My range is 105 and 110. So to check for functionality, 5 went in, 105 came out. 10 went in, 110 came out. 15 went in, 105 came out. Okay, this is technically a function. Okay, just because we have two x values that produced the same y value, that is allowable. Okay, so you can have multiple numbers pointing to the same output or range, right? What you cannot have is a domain or input giving you multiple outputs. Okay, I don't know why I put an E on there. Okay, so let's look at our next example. So domain, range, and is it a function? So again, domain is my x values, range is my y values. So I can go down the list. I have a -2, another -2. And if you have a real repeat in your domains, you need to be paying attention when it comes to checking whether or not it is a function. Okay, I have a -1, a 1, and a 2. My range then would be -1, 0, and 1. Okay, I have repeats in my y column. That's okay. What I am concerned about is repeats in my x column. So for this to be a function, this -2 needs to produce the same y value, right? So -2 went in, gave an output of -1. -2 went in again and gave an output of +1. So this is not a function, right? This -2, the repeat in the x value is where we need to pay attention, right? It has to produce the same output or y value every time. Looking at functions, substituting into a function. So this is called function notation. We have f of x. This right here is find the value find the value if f of x equals 5 over x plus 2. Right? So this right here is read f of x, and g of x is equal to -2x plus 3. So what this is asking me to do, right here in example A, find f of 3. Because this is no longer an x right here, they are telling me that anywhere in that function, if I had an x, I am substituting in a 3. Right? We are used to y equals equations, right? Y equals 5 over x plus 2 if x equals, and then they give us a value. So let's say 3. In function notation, the letter out front tells us which function, that's like the name of the function, tells us which function to look at. And then the value in the parentheses is what we are subbing into that function, right? So I am going to use this f function, and I am going to say 5 over x plus 2, except now they tell us that x is 3, right? So instead of x plus 2, I am going to write 3 plus 2. Right? And then I'm going to use order of operations. I'm going to do that addition in my denominator spot, and then 5 over 5 is equal to 1. So f of 3 is equal to 1. In example B, we're changing the x value to -4. So I am still going to use that f function of 5 over x plus 2, but now I am going to sub in a -4 for x. So I can finish out the math here. Right, I could leave that as a fraction, f of -4 equals 5 over -2, or -5/2. I could put that into the calculator if I needed to. Right, I would get -2.5. And then in example C, g of 6 is what we are asked to find. So we are now going to swap over to this function here, right? G of -6 is equal to -2 times -6 plus 3. Okay, I like to put parentheses when I substitute, and it is multiplication, so I can pay attention to the signs. Right, -2 times -6 is 12, positive 12. 12 plus 3 then is 15. Right, so if I sub a -6 into the g function, I get -15. Another review concept, super important, Algebra 1 concept, rate of change, also called slope, that is equal to, some people say rise over run. We're going to just kind of list out every possibility here. Rise over run. Some people call that change in y over change in x. Okay, and to find that we need a couple of points on the coordinate plane, right? So we could say y2 minus y1, subtract your y's, divided by x2 minus x1. Okay, it does not matter which one you call x1 and or point 1, point 2, y1 or y2, as long as you keep the point together, right? So everything from your first point needs to be stacked on top of each other. Everything from your second point needs to be stacked on top of each other. So finding the slope of a line going through these points, okay? And it's helpful to just label out your points. So it's helpful to just say, okay, this is point 1, this is point 2, okay? And I know I need to subtract them. So y value number 2 minus y value number 1, right? Don't forget, it's always x comma y. And then I'm going to subtract my x values, x value number 2 minus x value number 1. Okay, and I had that double negative there, so I made sure to put that in parentheses. Just kind of reviewing what I was talking about, right? 1 comma -2, those are together right here, right? And then my second point, those are together right here, right? So that helps me get the answer correct when I make sure that everything is stacked appropriately. So now I will just do the math, right? -2 minus 4 is -6. 1 minus a -1, right? This double negative gives me addition. So this would have a slope of -3. Okay? If I swapped my points, right, it would just change my signs in my fraction. I would still get a same slope of -3. Okay, here in example B, again, I'm going to label my points, right? There's point 1, here's point 2, y2 here, minus y1 over x2 minus x1. I do my subtraction. 9 minus 6 is 3. Negative 1 minus 2 is negative 3. And when I divide that out, I get a slope of negative 1. So if you have a graph and you have nice grid to work off of and whole number points, right? So I have right here, I know that this is on a grid line. This is on a grid line. I can count out my slope, right? Change in y. This is shortcut. This little triangle stands for delta. Change in y. Delta means change in, right? So change in y over change in x. Right, I can count this out. I see that my y value goes down 2. I see that my x value goes up 3. So I have a slope then of negative 2/3. Right, that's faster than finding these coordinates and then setting up your equation, right? 0 minus 2 over 3 minus 0, right? It's going to get me right to this same slope. But if you have a picture of the line with the grids and you see points that cross perfectly on the grid lines, I would just go ahead and try to count things out. So that brings us to the end of our first lesson. Please complete the assignment and get it submitted.